Assalamualaikum everyone. We are from Group 1. For our electromagnetic assignment, we are decided to choose magnetic levitation, Maglev, as our main topic. So, before we proceed, let me introduce our team member. The first one is Muhammad bin JUMALI. The second member is Muhammad Ashraf bin Abdul Razak. The third member is Muhammad Zafri bin Muhammad FADZLY. And the last one is Muhammad HANIS bin Muhammad Izzat. So, what is electromagnetism? So, electromagnetism is studies about interaction between electrical charges and current according to the Maxwell equation. So, where electrical charges create electrical field while moving charges generated magnetic fields. This is really important to understand how changing magnetic field induce the electric current. So that's why electromagnetism become the backbone for the technologies such as electric motors, generator, and communication device.
So we move to the next part, which is the challenge of the train technology related to electromagnetic theory. So modern train systems heavily rely on electronic equipment and an intricate electrical system, making electromagnetic compatibility (EMC) issue and a challenge problem. So these are following a few of the major obstacles related to AMC train technology. So the first one is the eternal interference, which is the electromagnetic field produced by the trained electronic equipment may also interfere with other systems due to the potential for severe interference caused by the nearby electronic equipment. So the next one is the interference from the outside sources, such as the wireless devices, cell phone towers, radios, and television and transmitter and other outside the sources also can cause electromagnetic interference in trains. So the third one is the regulation adherence. So train system have to abide by the stringent AMC standard, which is might be difficult to do. So infraction of this rule may lead to penalties, legal actions, and harm to the train operator's reputation. So the last one is the equipment compatibility. Another major issue is making sure that every piece of the electrical equipment about a train is compatible with other pieces. When technologies from the manufacturers are utilized on the same train, this becomes even more crucial. Problem with compatibility might result in faults and potential dangerous situation. So the next slide, we move to the challenge globally. So the first one is the harmonization and compatibility. The challenge lies in establish worldwide guidelines for the train technology, grounded in electromagnetic principle, to guarantee smooth integration and interoperability of rail network across the device nation and areas. So the next one is infrastructure alignment, keeping train electromagnetic system interoperable with different rails infrastructure across the world, including different power supplies, system signaling technologies, and also the track design and challenge. So the third one is the operation across the border. So the problem is the dealing with the issue of electromagnetic compatibility that arise with when train travel over the international boundaries. Its various nations might have the issue different power source, signaling system, and also the regulatory framework. So the fourth one is the sustainability energy sources. So using electromagnetic technology to power trains is sustainable and internationally applicable manner while taking into an account the availability of renewable energy sources and also minimizing the environmental impact of train technology. So the last one is integration of high-speed rail. So the challenge lies on the integrating high-speed rail system worldwide, given that the use of electromagnetic population technology necessity standardization of power distribution techniques, signaling system, and safety measure. So we move to the challenge locally. So The first one is antiquate infrastructure, which is it can be difficult to upgrade the current rail infrastructure to accept the contemporary train technologies based on electromagnetic principle, particularly in areas with antique of aging rail lines, such as monorail or LRT. So it might be some difficult to do. So the second one is the variability in power supply. So implementing electromagnetic based train technologies that demand constant and standardized power input might provide a problem because the local various in power supplies include voltage and frequency is different and changes. So the third one is adherence to the regulation. So the difficulty lies in the following regionally: specific safety and electromagnetic compatibility laws, as well as negotiating the regulatory environment to obtain the license and certification. So the last one is the acceptance in the community. So the challenge lies in gaining local community acceptability for the application of electromagnetic theory based on the train's technology, while resolving the issue with noise, safety, and aesthetic of the rail system.
So the another part that we took to finish my task is about the commercial among the maglev train. So the first is the main market. For the commercial is transport technology has advanced significantly with the introduction of the maglev, which is the magnetic levitation train. The development of extremely fast frictionless train has attracted investment from several nations worldwide. So the another market is a global market. We choose to took two example from the two country, which is Japan and also China. Japan has been leader in the development of maglev technology. The Central Japan Railway Company through JR Maglev, the full name is Japan Railway Maglev, has been working on the Chuo Shinkansen maglev system. This system operates to provide high-speed connection between the Tokyo and Osaka, potentially decreasing travel time. In addition, the firm of East Railway Japan Technology offer the maglev train as a means of exerting pressure on. The second example is that China has been making significant investment in maglev technology since its launch in 2004. The Shanghai Maglev train by Shanghai Maglev Transportation Development Co. has been reconnecting the city center to Pudong International Airport by means of the transport technology. Furthermore, Chinese enterprises such as CRRC, China Railway Rolling Stock Corporation, have been investigating and refining their maglev technology for the internet application. And then the commercial is for local perspective. Is from which is we choose two country also the Germany and also the Korea. Germany was among the first country to use maglev technology, especially with the transport initiatives. Only the Shanghai Maglev line saw the commercialization of the transport technology, despite it having been tested and demonstrated through the world. Subsequently, plans were afoot establish a maglev train network between Seoul and Incheon International Airport, with South Korea spending heavily in this technology. Still much have changed since in the terms of investment and commercialization status. Although there were going research program in the United States and various research program pertaining to maglev technology, there were no operational commercialized maglev line. They were planned to build the Notus maglev, a project that sought to line Baltimore and Washington DC.
Competition, the main. The essence of the competition between companies and countries to enhance the efficiency and speed of maglev train, which ultimately benefit communities and economic development. Globally, the maglev train emerged as the ideal solution for enhanced transportation on a global scale. Witness its transformative capabilities in action, such as remarkable 30-kilometer Shanghai maglev system linking Pudong International Airport to downtown, boasting a groundbreaking top speed of 430 km per hour. This high-speed marvel not only revolutionized long-distance travel but also proved its efficiency for daily commuting. Furthermore, Maglev's versatility, the lean more system in Aichi, Japan, designed for the 205 World Fair, spanned approximately 9 kilometers with 9 station stops, operating at speed of up to 100 km per hour. It stands as a statement to Maglev's suitability for both short-distance and daily transportation needs. The global perspective underscores Maglev's pivotal role in shaping a more efficient and dynamic future of transportation. Locally, Malaysia contemplates the introduction of Maglev train, notably in discussion about a potential line from Singapore to Johor. As mentioned by Sultan Ibrahim Sultan Iskandar, this presents exciting economic opportunities and infrastructure benefit. Environment, however, environmental impact and construction costs pose valid concern in the decision-making process.
Okay, after the some of the competition, we we took about the part of the opportunities between the other country for the maglev train. So by connecting far off places more quickly and enabling access within a few hours, maglev train have the potential to completely transform international travel. They offer a chance to drastically cut the amount of time needed to travel between important hubs, which could change how commodities and people are transported across international border. And additionally, by using less energy and emitting fewer carbon emission, this trend support international effort to mitigate climate change and contribute to sustainable transportation solution because they increase communication between cities and regions. Maglev train present chances for economic growth on a local level. They boost the business activity along their road on increase tourism and generate new job possibilities. These trends can also relieve traffic on regular rail network and roadway, providing commuters with quicker and more dependable ways to go around their own city or metropolitan area. Local may experience more convenience and a better standard of the living because of this improved connectivity.
So, in conclusion, Maglev give a few of advantages and disadvantages. So, one of advantages of Maglev is it can travel at much higher speed and also more energy efficient and also smooth and comfortable ride. But the Maglev also have disadvantages such as expensive to build and maintain in the early construction, and it also generate noise during the traveling at high speed, especially during the residential area. So to sum it up, Maglev's technology is like magic for transportation. Instead of using the wheel, just like a traditional train, it floats on magnets, making train go super fast and smoothly. What even cooler is that it's good for the our planet, no noise, no pollution. Imagine train moving silently and quickly, connecting places faster than ever. So Maglev is not just about speed, it's about making our cities better and be kind to our environment. So get ready for future where train glide effortlessly, making travel not only fast but also more awesome. That's all from us. Thank you and Assalamualaikum.